Welcome to Math 95, Section 1.1, Qualitative Graphs. So, what is a qualitative graph? What are graphs, right? We've seen graphs before in other classes and things like that. So what's the difference between a qualitative graph and the graphs we've seen in other classes? Well, a qualitative graph very simply doesn't have exact specific numbers. Most notably, we will have no scale on either the horizontal or vertical axis. So when we draw a graph, we won't have any numbers or values on these. We're going to have some sort of symbols to represent, or not symbols necessarily, could be symbols, or words to represent the situation, but we're not necessarily going to have actual data values. And the reason why is because it's a qualitative. Qualitative just kind of is meaning kind of a general graph. We're not getting a real specific exact quantitative graph, which is actual values. So an example could be, say, a car accelerating over time. So put time here, speed here, right? Let's say it's a car getting on the freeway. So they start out, they're not going very fast, okay? Maybe let's say they're stopped at a stoplight, getting on the on-ramp. So they're stopped, they speed up fairly quickly to get up to speed, and then they get up to speed, and that's the speed they're going. So there's a qualitative graph. Not the only possible qualitative graph. Maybe the person took off kind of slowly and they just kind of puttered along and then they quickly hit the accelerator to get up to speed. So there's a lot of different graphs you can create for this situation. Without any more information, there isn't necessarily one singular correct answer. But what this graph shows is that as the time passes, the speed increased up to a certain point and leveled off, which is what would happen as we get onto a freeway, right? We get onto the freeway, we increase speed to freeway speeds, we level off, we don't just continue going up and up and up and up, otherwise we get a lot of speeding tickets. Now, time and speed. These are important things. These are our variables. Variables, by the nature of the name, are things that vary, they change, and those are traditionally x and y. Now, one thing I'm going to really push you on this term is to get away from the idea of x and y. And we want to use appropriate variables, and we want to understand that variables aren't just these two letters, but they represent things. Okay? So let's continue with that example of getting onto your speed as you get onto the freeway. Okay? So we are modeling the speed of a car as it gets onto the freeway. Okay, so there's a couple things going on here. First of all, we have this situation, right, that we've talked about, and we need to identify what our variables are. In any situation, any mathematical problem for sure, but in most situations, there are things that can change. And so what are the things that can change here? There's two. The two things that can change, one is very obvious, the speed of the car, right? So one is speed. Now what's the other thing that changes? Now we already did the qualitative graph of this, so it kind of, jumps the gun a little bit, so it's pretty obvious. But it's not written down in here, is it? But as we read this, it's the speed of the car as it gets onto the freeway. So we can see that that could be a couple things, right? If we really want to get real nitpicky, we could say, okay, that's its distance from this freeway. But what's really easy is time, right? As a car is getting onto the freeway, well, that's the time from when it started to get on the freeway to however long it takes. So our other variable is time, okay? So these are our two variables in the situation. Now what's more important than just identifying them is identifying which one is which. And now you're like, which one is which what? We just said variables. These variables have one of two classifications, okay? And that is either the independent or the dependent variable. Okay, sorry, I'm left-handed. I have to kind of write over that way, so I'm going to walk across the board. All variables in a problem like this can be classified as either independent or dependent, and they mean exactly what they sound like. Okay, an independent variable is one that can change on its own. It doesn't require anything else. Where the dependent variable relies on another variable to give its value. And so if we look here, which one of these is independent? Which one of these kind of can change without the other one affecting it, right? Speed, well, our speed is dictated by how long it's been since they started driving, right? But our time, that doesn't matter how fast we were going. So in this case here, our time is the independent variable, and our speed is the dependent variable. Now, a cool trick, or cool not trick, but a cool fact, okay? The passage of time is, and I'll put this word almost, always the independent. Okay, so the passage of time is almost always the independent variable because it doesn't affect, it's not affected by other things, right? Other things are affected by time, right? As time went from A to B, things changed. Okay, as time goes from 0 to 5, their speed changed. But as their speed changed, the time wasn't forced to change. So whether they sped up or slowed down, time was still passing. Okay, so time was independent of the speed, but the speed was dependent upon the time. So this idea of identifying what our variables are and identifying which is the independent and dependent is crucial to your success, not just in this class, but in all future classes in mathematics. Okay, and this is something that on almost every example problem we're going to do, we're going to clearly state what our variables are, which one's independent, which one's dependent. And I highly recommend on all the problems in the homework, if it's a situation like this, do it as well. If there's some story, if there's some situation, clearly in your head identify what the two variables are and which one's independent, which one's dependent. It is going to help you so much. And I guarantee you on the test, I will ask you, here's a situation. What's the independent variable? What's the dependent variable? Guarantee you 100% I'm going to ask that. So, now, we talked about x and y, right? And typically, our independent variable is the x, and our dependent variable is the y, okay? If I give you just a random problem and say, hey, bam, here we go, the independent variable is usually the x, the dependent variable is the y. If I'm flipping those, I'm either clearly stating the problem that's happening, or I'm being a bit of a mean teacher and trying to trick you, okay? I'm not a mean teacher, I'm not going to try and trick you. So this is, if I use x and y, this is pretty much how it's always going to be used. Now, does x tell us anything that says time? No. So typically, if these were my variables, then instead of using x and y, what I would choose would be the variable t and s, because those more accurately represent what they're actually representing, right? T is a much better representative of time than x, and s is a better representative of speed than y. So when you're choosing your variables and you're choosing what letter to represent those variables with, okay, choose one that matches, right? Don't just always jump to x and y, choose an appropriate variable, okay? So, let's do another problem. Okay. So, I'm not going to write this up here because I don't have a lot of board space and I don't want to take a ton of time. I'm going to read this to you. If you need to, it's a video, so you can go back and write this problem down. Just closed captioning will be on this. If you're watching it right away, it might not be there yet, but it will show up. Okay. So, if we let P, the letter P, represent the average price of a home in Salem, Oregon, right, our lovely town, and let T represent the number of years since 1990. Okay? So what I want to do is clearly identify what our two variables are, identify which is the independent and dependent, and then I want to create a qualitative graph of what this might look like. Okay? So, the problem said let P, so we have variable P, that's an easy one, it tells us in the problem, is the price of a home in Salem, Oregon. So this is the price of a home in Salem, Oregon. Okay, and our other variable it tells us in there is T, and this is the years since 1990. Okay, now a quick note, anytime you're dealing with a problem that has years in it, we almost always will re-index those, and what that means is we'll do something like this. We'll say it's years since some set. So 91 is 1, not 1,991. Because when we do things in our calculator, it doesn't see 1990 as, oh, it's this year. It sees it as the number 1,990. And so it's really important that we do that because it's going to make our calculations much simpler. And as we get on in this term, we're going to do things called regression in our calculator, which is where we'll give it a bunch of points and stuff like that and make it give us an equation. And if we use like 1990, 1991, 1992 instead of 0, 1, 2, it's going to give us much bigger and weirder numbers to deal with, whereas if we use those 0, 1, 2, it's going to give us cleaner situations. Okay? So, what is the independent and what's the dependent here? Well, that's pretty easy, right? Because we said the passage of time is almost always the independent variable. And here, years since 1990, that's the passage of time. In this case, it's years, whereas the last problem, we might have considered that passage of time in seconds. And so that's really kind of a very simple, nice, easy one. So if this is the independent, that must mean this is our dependent variable. So, when we draw our graph, the independent variable is always on this axis. This horizontal axis is always our independent variable. So this is going to be our t. Okay? And our vertical axis is always our dependent variable. And so in this case, p. Now, knowing the ages of most of you guys, you probably aren't too familiar with housing prices. But I can tell you they are going up. And for the most part, they started out pretty low. 1990, housing prices were not super expensive. And so they weren't zero, right? So if we started here, what this is saying is when t is 0, which is years since 1990, so that's the year 1990, the housing price was 0. So that would mean that in the year 1990, houses were free in Salem. You could just go like, hey, look, there's a house, I want it. But that's not true, right? So we can't start here. We need to start up somewhere so that in 1990, there was some level of price. Now, what that level is, we don't know, and that's why it's a qualitative graph. We don't put an exact value, but we know it's not 0. Okay? And so the next thing we need to do is we say, okay, have housing prices gone up, gone down, what's gone on? Well, for the most part, they were going steadily up, okay, not necessarily at a fixed incline, it might have had some, little wiggles. So we could say like, okay, well, it kind of went up, might have had some little wiggles. And then for those of you who are unfamiliar with the economy in 2008, I'm not sure how many of you were little babies at the time, there was a big market crash in 2008 called the Great Recession of 2008, right? And that was caused by the housing bubble bomb. So what happened is housing prices tanked. They didn't go down to 1990 prices, but they dropped a significant amount. And then they've rebounded ever since. And so there's a qualitative graph. Now this is a much more informed one than you might have made. As somebody who is not familiar with housing prices, you may have been like, they go up, and that would be perfectly fine, right? The amount of information that you have to the situation is going to dictate how accurate of a graph you can make, right? I have purchased a home, and I know homes I've, older and have dealt with those things, so I'm aware of those kind of ebbs and flows of the housing price. But for somebody who's not, doing that would be perfectly okay. And that's the cool thing with a qualitative graph. Again, there's not one right answer. And somebody who knows even more than me would be able to give an even better graph than this. Maybe this dips more. Maybe this goes back up much sharper. Maybe it just went poof, right? So those are all things that are kind of intrinsic in the qualitative graphs that are really nice. But what's really important about a qualitative graph is it gives us a general sense of what's happening. Okay? We don't necessarily look at this and go, ah, boom, that's what's happening. But we have a general idea of what's going on. Okay? Let's do one more example, and that'll be it for the day. So, let's say we walk into a bathroom. The bathtub is full, not overflowing full, but we filled up the bathtub. Okay? We get in the bathtub, we soak in there and enjoy a nice bath. We unplug it, hop out, and drain the bathtub. Let's create a qualitative graph that shows the volume of water in that bathtub from when it was full to when it was empty. Okay? So our variables here, well, we have V, and this is the volume of water. And what's our other variable? Well, again, as time goes on, right? This is a very common situation where time is our independent. Not the only one, but it is a very common one. This is time. Okay? Again, times are dependent, volume of waters are independent. Okay? So, what do I label this axis? Right? It's always important to label your axes, right? You don't have to use the words, but at least the symbols. What do I label this? That's right, time, because it's independent and the horizontal axis is always the independent. So, T, which must mean this is our volume, V. Now, what I want to talk about is how to start this. Okay? Can I start at the origin? So just to remind you guys, the origin is this point here at 0, 0. Do I want to start there? So if you back up and remember the problem, right? We came in and we'd already filled the bathtub up, right? It was already full. So at time 0, from when we got there, it's no longer at a volume of 0. So we need to start at a full bathtub. Okay? Now this point here is what we call the vertical intercept. Okay? Because this is our vertical axis, it is a vertical intercept. We're going to really define this out in just a minute. Okay? But I want to kind of really pay special attention to that. That's our vertical intercept. So now what happened? Okay? Well, the first thing we did was what we got in the tub. Now, the volume of water in the tub didn't change. The level may have increased, right? But the volume stayed the same, right? And so remember, volume is the amount of water in there. Okay? By us getting in there, the amount of water didn't change. It may have, risen up in the tub. Let's say it didn't overflow or anything like that. So it stays the same. Okay? And as we soak in our bath, the volume of water stays the same. It stays constant. But then we pull the drain and we hop out. Okay? When a bathtub is really full, it's going to drain faster because that force of that water is pushing down and draining quicker than when there's just a little bit of water like kind of trailing at the back end and going a little slower. And the reason why I care about that is because that tells me that my graph isn't just going to go straight down, right? It's not just going to go from there to empty. It doesn't. If you have a bathtub that's only empty, that's terrifying because I'd be worried that even me as a big guy would get flushed out. But what happens is it drains pretty quickly and it slows. And so that tells me that my graph is going to kind of be a little curved. Like this. And this point right here that I made, this is our horizontal intercept. Simply the point where the graph crosses the horizontal axis or touches the horizontal axis. So vertical intercept, horizontal intercept. All they're talking about is at what point does our graph touch or cross that either vertical or horizontal axis. Okay? So bam, there's a qualitative graph for the volume of water in the bathtub after we got it, or after it was full. It's full, we got in, its volume stayed the same, we pulled the plug and it drained. Now, let's talk about these intercepts a little bit more. Now, if you remember, hopefully you remember points and coordinate points, right? These kind of parentheses, x, y, these ordered pairs. What's really cool, okay, I don't need this, but I want to keep the graph up so we can refer to it. So the vertical intercept okay, we roughly know its coordinates. So if we look at this, what are the coordinates of this point? Well, if you remember, it's x comma y, right? So it's the input, then the output, or the independent variable, then the dependent variable. Sorry, inputs and outputs we'll talk about later this week. So the independent variable here, this point is at 0. So I know this is 0, even though I don't know these numbers, right? I don't have any numbers on this, but I know that this is the origin, this is 0. So this vertical intercept is always when the input is 0. Now the output is some number, so we can say, whatever, we'll say m. Okay? Now, similarly, with the horizontal intercept, here, okay, I don't know what my input is. So let's just say that's an n. Okay? But what's my vertical value? What's my output? What's my y value? Right? Again, that's 0. So I know that is the point 0. So what's really cool about this is when we get into functions and things later on in equations, if I ask you what's the vertical intercept, you go, okay, well, vertical intercept is when the independent variable is 0. So we're going to develop skills, and you already have some of these skills to solve when the independent variable is 0, to figure out what that dependent variable is. And for horizontal intercept, we go, oh, that means the dependent variable is 0. So I need to figure out what independent variable has a dependent variable 0. And we're going to talk about how to do that this term. Those are going to be some of our kind of driving questions, is things like that. Like, if our independent variable is this, what's our dependent variable, and vice versa. Okay? So, there's qualitative graphs. Really big thing to take away, right? Remember, with all of these problems, in your head, if you can, identify what are the two variables, which one's the independent, which one's the dependent. Okay? You can think through that every single time and get that down. That gives you so much power with these problems. It makes so many things simple. It eliminates so many easy, simple mistakes. So, that's it for our first lesson. I hope you had fun, and I'll see you for 1.2.